How to calculate dynamic correlation in Python time series. Imagine watching how two stocks move together over time, not just knowing if they are generally related. That's what dynamic correlation helps us see. It shows us how relationships between variables change as time passes. If you want to understand these shifting ties in your data, Python has some great ways to do it. First, think about your data structure. You usually have a table with rows for each time point and columns for different variables. For example, daily stock prices for two companies over a year. The goal is to see how their relationship evolves day by day or over specific periods. Most people start with static correlation, which measures the overall relationship across the entire dataset. You can do this easily with pandas dataframe's corr method or numpy's correlate function. But this only gives one number for the whole period, missing out on how the relationship might have changed. To capture the changing nature, you need to estimate correlation at each point in time. One way is to use a kernel function, which is like a weighted average that emphasizes data points near a specific time. This way, at each moment, you calculate a correlation that reflects only the nearby data. Moving this kernel across your data creates a series of correlation values showing how the relationship shifts. In Python, there's a tool called the timecorr library designed for this purpose. It takes your data and a kernel function, then computes a correlation matrix for each time point. The result is a three-dimensional array where each slice shows the correlation between variables at a specific time. This method captures the fluid nature of relationships in your data. If you prefer a simpler approach without extra libraries, you can use pandas' rolling window feature. Choose a window size like 30 days, then calculate the correlation within that window as it slides across your data. For example, you might write dfr1, rolling window is equal to 30, corr dfr2. This produces a series of correlation values over time, showing how the relationship between the two variables changes. Remember, the size of your window or the shape of your kernel affects your results. Smaller windows catch quick changes but can be noisy, while larger ones smooth out the data but might miss short-term shifts. For smoother results, you can use Gaussian kernels, which weight data points more gradually based on their distance from the center. Visualizing these dynamic correlations helps you see patterns and understand how relationships evolve. You might notice periods where two variables move together strongly, then drift apart. This insight is especially useful in finance, economics, or any field where relationships are not fixed but change over time. In summary, calculating dynamic correlation in Python involves moving beyond a single static number to a series of evolving correlation values. You can use specialized tools like the timecorr library for kernel-based methods or pandas, rolling functions for simpler calculations. Both approaches give you a clearer picture of how variables interact across different moments, making your analysis more responsive to real-world changes.